This problem focuses on understanding how the GroupKFold algorithm works in cross-validation. We'll examine how it splits data considering group structures. Let's dive in. I have a dataset with 15 samples that needs to be split for cross-validation. These numbers define the groups each sample belongs to. Notice Group 0 has 3 samples, Group 1 has 4, Group 2 has 3, and Group 3 has 5 samples. This unequal distribution is crucial. I want to split the data into 3 folds for cross-validation. This is the central question. I need to determine which statements accurately describe how the GroupKFold algorithm divides the data given the group structure and the 3 folds. This statement explores whether each fold will have at least one sample from every group. This statement focuses on whether GroupKFold keeps samples from the same group together in the same fold. This statement tests my understanding of whether the fold sizes will be roughly equal. This statement assesses whether GroupKFold will make sure every group appears in at least one of the 3 folds. This is a quiz about how GroupKFold, a method for dividing data into folds for cross-validation, works. I'll be evaluating a scenario. I have 15 data points to work with in this quiz. These 15 samples are divided into 4 groups. 3 samples in Group 0, 4 in Group 1, 3 in Group 2, and 5 in Group 3. This grouping is important because GroupKFold keeps samples from the same group together. I will divide my data into 3 folds for cross-validation. This statement is false. Because some groups are larger than the number of folds, it is impossible for every group to be represented in each fold while keeping samples of the same group together. This statement is true. That's the whole point of GroupKFold. It ensures no data leakage by preventing samples from the same group from being split across different folds. This statement is false. Because the groups have different sizes and GroupKFold keeps groups together, the folds will have unequal numbers of samples. This statement is true. GroupKFold will make sure that every group appears in at least one of the 3 folds, to ensure a complete cross-validation process. This describes the type of problem we're tackling. We're using a technique called GroupKFold cross-validation. It's a way to split our data to train and test a machine learning model fairly, while considering groups of similar data points. I have 15 individual data points I'm working with. Think of each data point as a single piece of information that I'll use to train my machine learning model. These numbers define groups within my data. For example, the first 3 samples belong to Group 0, the next 4 samples belong to Group 1, and so on. These groups are important because I need to make sure the model is trained and tested using data from different groups to avoid biases. I'll split my data into 3 parts. Each part will be used for testing my model's performance once, while the other 2 parts will be used for training. This is the specific algorithm I'm using to perform this splitting. The key feature is that it keeps all samples from the same group together in the same fold. This is the first of 3 parts of my data that will be used for testing the model. The algorithm ensures that all data from a specific group is contained within this test set or not at all. The second test set, again maintaining the group structure. The third and final test set, with the same principle of keeping samples from the same group together. I'm looking at a scenario using GroupKFold, a technique in machine learning for splitting data into folds for cross-validation. This helps us evaluate how well a model generalizes to new, unseen data. I have 15 data points to work with. This is the size of my dataset. I'll be splitting these into groups for cross-validation. The 15 samples are organized into 4 groups. 3 samples in Group 0, 4 in Group 1, 3 in Group 2, and 5 in Group 3. GroupKFold uses these groupings to ensure that samples from the same group remain in the same fold during cross-validation. This is to avoid data leakage, where information from one fold might inadvertently influence the results of another fold. I want to divide my data into 3 folds, meaning I'll have 3 separate parts for training and testing my model. GroupKFold is the specific algorithm used. It's designed to keep samples from the same group together across all folds, ensuring each fold has a balanced representation of all groups. The goal is to answer multiple choice questions about the resulting folds from applying the GroupKFold algorithm to this data. Based on how GroupKFold works with my data and the number of folds, I need to determine which statements about the folds are accurate. Statement A says every fold will contain at least one sample from each of the 4 groups. Statement B says samples in the same group will always be in the same fold. Statement C says the number of samples will be evenly spread among the 3 folds. Statement D says all groups will appear at least once across the 3 folds. The question focuses on the characteristics of the folds that GroupKFold creates with the given parameters. What are their properties? This is the title of the problem. I'm dealing with a scenario involving GroupKFold, a technique used in machine learning for cross-validation. I have 15 data points that I need to split for cross-validation. This is the size of my dataset. My data is grouped. The numbers represent group assignments. There are 3 samples in group 0, 4 in group 1, 3 in group 2, and 5 in group 3. I need to ensure that I don't split the groups across different subsets during validation. I want to divide the data into 3 folds for cross-validation. This means I'll use each fold as a test set once, with the others used for training. This is the core question. I need to determine which statements accurately describe how GroupKFold will split the data based on the information given. This statement asserts that the GroupKFold algorithm will respect the group structure and maintain samples within the same group in the same subset. This is a core principle of GroupKFold, ensuring that samples from the same group are not split across different folds to prevent data leakage. This statement claims that every group will appear in at least one fold. This is to ensure each group is represented in the validation process to prevent bias. Considering that there are 4 groups and 3 folds, it's inevitable that at least one fold will contain samples from more than one group. The algorithm's name highlights that it's designed to create folds while considering groups of data. It aims to prevent information leakage by keeping samples from the same group together. The parameter nsplits determines the number of folds to create. I'm tackling a problem involving GroupKFold, a technique used for cross-validation in machine learning. It's all about splitting data into groups for training and testing a model to get a good idea of how well it generalizes. This scenario is a great way to test your understanding of how GroupKFold works. I have 15 data points that I need to divide for cross-validation. This isn't a huge dataset, making it easier to track what's happening with the folds. These numbers represent groups. Each number signifies the group a sample belongs to. I have 4 groups in total. Group 0 has 3 samples, Group 1 has 4, Group 2 has 3, and Group 3 has 5. This grouping is important because GroupKFold keeps samples from the same group together. I'm splitting the data into 3 folds for cross-validation. This means I'll have 3 separate sets of data, 1 for testing, and 2 for training for each iteration of the process. The goal is to figure out which statements are true about how the data is split into folds using GroupKFold with the given parameters. This statement tests if every group is represented in each fold. I'll need to check if that's possible with the given group sizes and number of folds. This statement is about the core concept of GroupKFold. Are samples in a group always kept together? Here, I'm checking if the samples are evenly distributed across the folds. Given the unequal group sizes, this might be tricky. Similar to statement A, but focusing on whether at least one fold has samples from each group. The difference is subtle but important.